Hello. So, I was just thinking there's not enough podcasts in the world, and I need to make one, obviously. There's just not enough selection. So, obviously we're all trapped in quarantine right now. We're all looking for things to do. And for a little while now, I've had an idea of starting some kind of video series of some kind, essentially just talking about uh, my passions, things that I've been interested in for quite a long time, um, and just taking what I have and then sharing that with the world, or the two people that might actually watch this. Um, Now I do understand that the things that I might want to talk about might be extremely boring. They might actually make you want to pause the video immediately. But my suggestion would be to just play it at 1.5 times speed, go somewhere in the middle, and see if you like anything I like saying. If not, turn it off. Otherwise, my goal is to try and make these videos as short as possible and to be as pointed as possible, to not deviate so much and go on tangents. And I want to actually be very pragmatic about what I'm saying. I don't want to overwhelm, and I don't want to start saying 30 different things about one topic. So today, what am I talking about? I'm talking about specifically Albert Einstein, um, and in particular, I want to talk about um, who who was he, and why is he actually synonymous with the word genius? You think about it this way: how many geniuses have there been in the world? Many, many are born every year. Thousands upon thousands, even millions, probably exist in the world. Um, and so Albert Einstein is, this name that's associated with the word genius. He's someone that's admired in, especially the Western world. I can't really speak for, Russia and those places, but at least in the Western world, if you were to say he's a little Einstein, this child is an Einstein, or this person's an Einstein. Generally speaking, that means someone has seen something very uh, brilliant in you, and you have now been placed in this kind of category of people like Einstein, people that are very smart, people that are very articulate, that kind of thing. So, why does he deserve that at all? Why does Einstein, why should his name at all be synonymous with genius? What did he actually do to deserve that? And I think for most people, they just know Einstein. It's just one of those things. It's this kind of thing that people have said, and you just know. Oh, this Einstein kind of thing. But if you look into what he actually did, who he actually was, what were his ideas actually, um, you start to understand why they call people that are smart, geniuses, why they call them Einsteins. And today I just want to illuminate one aspect of this kind of thing that he came up with. So I want to take us back to the 1600s, and we have Newton. So to most people, Newton is also a genius. He's also just extremely smart. Um, Most people know Newton by his famous F equals ma. Everyone knows F equals ma. Everyone has heard of this. The apple falling on the head. He discovers this gravity thing. Everyone kind of knows, generally speaking. I mean, I'm not saying particulars, maybe you didn't even know the equation. Everyone knows this kind of general idea. And so, what I want to briefly mention is Einstein was kind of like, let's say, the next link. So here comes Newton in the 1600s, and then here comes Einstein in the early 1900s, 20th century, sorry. Now, Einstein was kind of the next big revolutionary shift within the field of physics. And specifically, both of them worked on gravitation. Both of them worked on gravity. Both of them worked on problems related to gravity and how to describe gravity, where you can make predictions, because that is ultimately what they were focused on, making predictions. Now, what did Einstein do that was any different than Newton? F equals ma. Yeah, everyone knows F equals ma. It's great, perfect. Okay, what is the difference? The biggest difference that you could possibly say between one and the other is that in one example, the math is very, 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 very simple for Newton. The math is extremely simple. It is very easy to get predictions out of Newton. Once you go into the realm of Einstein, the math and the level of sophistication that exists with Einstein is so tremendous that you essentially need to get a master's degree or a PhD in physics to understand what he's actually saying. It is so complicated. It is not possible that someone without any training in those specific fields would ever be able to understand or truly understand what it is he said. And I want to try and lay out exactly what I think is the most important difference between these two, and I don't want to cloud it with more and more confusion. With Newton, when you think about forces, you have an acceleration component and a mass component. I want you to forget what these words mean. I just want you to think of this. The mass is a number, and the acceleration is a number. And the force is a number. It is a number, and I don't care about measuring it. It doesn't matter. Just forget about all these things that you've learned. The important point to raise with Newton is that there is no value for the mass, and there's no value for the acceleration that you plug into that equation. Just essentially two numbers you're multiplying. There is no not allowed values. You're allowed to just put whatever you want into it. If I want to have think about a 3 million kilogram, lake, and I want to talk about it accelerating, I can do that with Newton. It doesn't matter. I can plug in whatever values I want, and I can get the force out. Now, that starts to break down once you realize that, well, actually, from what I've heard, the speed of light is the fastest things can go. I've heard that the speed of light is the fastest that things can go. And this is true. This is actually the truth. We're all made of these particles, right? Whether you think about it or not, we're all made of particles. And essentially there's kind of a maximum speed that we're allowed to go as a particle. There's a maximum speed you're allowed to go. And it turns out, just so happens that it turns out to be the speed of light. Now, the problem here between Newton and Einstein, and why Einstein is kind of the successor to him, is because Einstein realized that Newton, because I can plug in any acceleration I want, any value I want, it doesn't matter how big, it could be a Googleplex, that means that in Newton's world, I can apply essentially an infinite amount of force. I can apply as much force as I want, and I can continue just multiplying numbers together, and it doesn't matter how big they are, it doesn't matter how fast I'm going, it just doesn't matter at all. Einstein, based on some experiments that actually had happened, he realized that, well, actually, no, that's not true. The fastest that a particle, which is what we're all made of, so again, that's an equal footing, everything is made of particles, so you can ask, out of all the particles, how fast can they go? And it turns out that it's like 3 times 10 to the exponent 8 or something. Anyway, it's really fast, but it's nowhere near a Googleplex. It's nowhere near trillions and trillions. It is very fast though. And that is the biggest conceptual drift between these two people. Because in Einstein's world, instead of it, the forces and those kind of things, instead of allowing things to go as fast as they want, because that's what force is, right? You can just think about it as force being like me pushing something. There's a relationship between how fast my force is, how much force I'm applying and how fast I'm going. There's a relationship there, right? Because if I go really fast, I'm pushing a lot of force. Like you think about if you are asked to push something and it's really heavy on the ground, generally speaking, when you walk up to it and you're slowly pushing it, you're not going to get very far. You're not getting very far. And you can either think about this in the sense of it's not that I'm not putting enough speed into it, or you can just think about it as I'm not putting enough force on it, which they're the same thing, really. There's no difference. But with Einstein, though, you actually are not allowed to go past the speed of light. You are not allowed to go faster than that. So what that means is there's actually a restriction on how fast things can go. It is actually not allowed that things could have more force than whatever the speed of light could have, for example. But it's not allowed. It's just simply not allowed. And so essentially, like as the as something goes faster and faster and faster, there's a chart that you can get where it just shows you those asymptote, and it just shows you that as you get closer and closer and closer to the speed of light, you kind of hit this singularity where you're not allowed to go past it. Light can go as fast as that, but the funny thing is that light actually doesn't weigh anything. Photons is what they're called, are what light are, and they don't weigh anything at all, but they're the fastest things in the universe. And so it's really weird. If you want and you're interested, you can go more and look into that. But I want to say that the one important point to think about in the universe is that there is a speed limit to how fast things can move. Whereas in Newton's world, you can move as fast as you want to. It doesn't matter. It does not matter how fast you're moving. There's no condition for you're only allowed to go this speed. It just does not exist. Whereas in Einstein's world, it does exist. And so that's one big difference. And I'll just leave it here for now. But I'm going to pick up on this tomorrow, hopefully, and walk through a bit more about the conceptual differences between Einstein and Newton. Thank you very much.